We'll now conclude this roundtable, at least the initial presentations of the roundtable, with José Luis Simón, who will talk to us about the impacts of fracking in subsoil. He is a full professor at the Faculty of Earth Sciences, University of Zaragoza, author of over 170 scientific publications on structural, tectonic, and geomorphological structures. He is the creator and scientific coordinator of the Allá Geological Park and the creator and promoter of Helodia, a national seminar for geological dissemination that began in 2005, and also has won the Scientific Dissemination Award this year. And as we're running a bit behind schedule, let's introduce him without any further ado. José Luis Simón. You hear him? Yes. Good afternoon. Thank you, David Lafarga, UNED, the Ramon Sender Foundation, for allowing me to be here in this setting, in a forum where I feel overwhelmed. I don't know if I'm out of place here. But to take a bit of weight off my shoulders, let me say that I am no expert. I am a geologist, and geology is a key part of this. My specialty, tectonics, theoretically, doesn't have too much to do with fracking for hydrocarbons, gas, or oil. I am involved in active faults, in processes of fracturing in the Earth's crust and natural evolutionary processes, and that does have some things to do with this field, and it does make me a bit more authorized to speak. But basically, I'm here as a citizen who's slightly more informed than average, and has had to respond to some concerns from family, friends, and citizens of towns affected by some of these projects that have applied for shale gas survey projects have been asking me, and that has led me to read up and research and share what I found when I have an occasion such as this evening's. So I am here just in that role. My main message, getting straight to the point and skipping some of the things that have already been touched on, and I will only speak briefly to my main point is to point to the great contradiction that exists between the opportunity or threat when it comes to fracking. I'd say it's both. The problem is the opportunity is what they sell, and the threat is what they hide. That contradiction between what they sell and what they hide is what I'd like to show you today, especially with some examples that I know of. One in the Iberian mountain range, one of the only ones that I've had the chance to see a minimum amount of documentation to get an informed opinion. We focus on the fact that shale gas is a non-conventional resource, so obviously some unconventional economic expectations have been built around it of energetic independence, i.e. a better future than the present. It requires an unconventional technology that has been developed just a few years ago based on previous technologies that did not make it possible to extract shale gas. But as José Luis has said in the previous presentation, it involves environmental risks which are difficult to know, to address, and to handle. Could also be considered unconventional. So that the principle of caution should be applied. This is where it should be applied. But there are such economic expectations that this could cover all the costs that could be covered with this. This would be the field. The corrective measures that are applied straight off with the best existing technology, with the direct agents and processes that cause impacts, air pollution, surface water pollution, they are being applied. the water tightness of wells, the avoidance of filtration into the soil, and so forth. But I don't know if preventive, serious, rigorous research on all the conditions that may exist underground. Maybe we'll see things on the surface, but we don't see things underground. We can't monitor them. If you work 3 or 4 kilometers underground at pressures of 700 atmospheres, producing fractures that we cannot monitor in terms of how far they go, with fluids which we don't know where they're going to end up, this obviously involves risks that only with rigorous preventive measures taken before the fact could be addressed. Right now, I can't speak about all the aspects of environmental impacts, but I will focus on 2 that have to do with geological factors, and maybe I could tell you a bit more about. Some aspects, not all of them, but some aspects of pollution, especially that of underground pollution, and some bits about induced seismicity, induced seismic activity that we've already heard about. The pollution comes from the gas itself and the chemical additives of the fracking fluid, as we've heard about, and of deep salt water that could be stirred up in the fracking process. Nothing's been said about this yet. And the salt waters in deep aquifers tend to be very salty. They conserve salinity over long geological periods, and as we stir those up with the fracking fluid, it could cause that salt water to come to the surface, thus contaminating freshwater aquifers. So, toxic elements that are outside the water, that are in the rock, such as radioactive elements, arsenic, and radioactive isotopes. We don't know if they are in an inert state, but they could be stirred up due to the great volume of water being moved through them and the pressure. So these are the possible sources of pollution. These contaminants could reach the surface, or they could filtrate into underground layers. They could filtrate through during fracas, or with the water that is recovered. Oftentimes the way that water that's disposed of is to inject it back into the soil, so we're returning it to the ground. Leaks of these contaminants into underground layers or the surface could come from cracks in the casing of the well. This could be solved if the best available technology is used for the construction and the safety measures and the water tightness of the well and its safety casings were employed. But there are other aspects that are harder to control. The fractures induced in fracking themselves, or the natural faults and fractures that almost definitely will exist in the rock formations that contain gas and the gas above and below them.
Digamos, conectividad hidráulica.
So the hydraulic connectivity between the horizontal well in which we are introducing the fracking aquifers is one of the main issues in terms of soil or underground pollution. In this graph, it looks quite idyllic, but the possibility of fracking to have fractures and cracks to go bottom up is not considered, and it's a diagram that is used to say that in the States there has been very few cases of aquifers being polluted, at least due to the injected toxic fluids. Some scientific papers have proven leaks in Aragon coming from radioactive components or coming from methane pollution. The image of this tap water flaring and burning, and it's a way of showing or proving that this methane has not a biogenic origin, but rather an underground, the organic soil matter decomposition, and some methane leaks have been proven to come from underground drilling. There's some few cases, 2, 3, or 4, and recently there's been one case in which legal this family was supposed to be legally compensated because of this pollution, but there's very few cases that have been proven of pollution coming from fracking practices. The reason is due to the huge vertical distance between the rock bed that is exploded, the fractures or the crackings that are disseminated, and the depth at which we have freshwater aquifers. So these parameters, the depth of the wells, the depth of aquifers, and these are the variables that are used in this. This is the source of shale gas graph, in which Marcellus shale is given this distance of the safety distance, 1,000 meters cracks or the fractures between the aquifers and fractures. Where there's oil fields in the States, probably they use this water as fresh water and using just shallow level like 300 or 4 meter deep aquifers, even 200 meter deep aquifers, but gas is extracted from a depth of 3,000 or 4,000 meters. And the deepest vertical fractures are about 600 meters deep. So if we have 2,000 meters and we have 600 meters of fractures of cracks, the consequence is that we are safe and sound, and we have guarantees, according to the industry, that nothing coming from these cracks could go all the way up and pollute aquifers. And some papers have been published that provide some nuances. In some exceptional case, the depth could be 600 meters, but in non-negligible proportions, and these fractures, these cracks could go or could be longer and wider than these hundreds of meters, fractures that would go up to 350 meters, 100%. But if we add to that normal and natural fractures, we would come as high as 33%. Some pre-existing cracks and fractures would disseminate and would be enlarged and propagated. I'll leave it here and I'll go back to it. But just a couple of words to introduce induced seismicity, just to update some of the things that have already been stated. Seismicity activity produced by fracking is pretty low, because even if we produce a 600 seismic movement, that would correspond to an earthquake below 1, because magnitude is exponentially 10, put a power of 10, that would be -1, -2, -3, just non-perceptible earthquakes for human perception. So most fractures are not perceivable by human observers. But the problem is that sometimes water injected at high pressure is injected on tensional active faults. The definition of active fault in geology is quite complicated. That is, faults submitted to a high natural tension on the soil, on the rock, and probably the resistance is going to be overcome, and it's cycles of tension, relaxation, and depending on the moment in which we are going to be at in terms of this cycle, high pressure water could actually trigger an earthquake. And the natural tension are going to be already there, but water pressure is going to trigger it. And there's some proof of 3.8 and some more magnitude earthquakes that have been caused and have been perceived. And once we admit that a highly tensioned fault can be triggered or reactivated by the injection of high-pressure fluid, we have to be aware that all faults, even very strong faults, can have an impact and on 4, 6, or whatever dimension could be provoked by the fault itself in terms of earthquake levels. And this all these dangers and hazards may require preventive surveys, really accurate and serious, that should try to solve and provide reasons for the knowledge of the mechanical characteristics of the rock bed, the rock below or above this rock bed that could stop the propagation of such fractures and prevent pollution that may occur. Deep knowledge of the network of natural fractures. It doesn't make sense to say that we have controlled our process if we have a lot of fractures and cracks through which pollution may disseminate. Of course, aquifers. We need to know aquifers, which are the flow networks between the different aquifers concerned, and whether they can be reached by the pollution occurring, and of course, active faults that may be triggered or reactivated by the injection of fluids. This may require serious and accurate environmental impact analysis, a lot more accurate and serious than in the other operations done by the industrial sector, because of the lack of control of what happens in these operations. And this survey should be required, be made compulsory, and some citizens, I myself include myself into these citizens, are quite concerned about the fracking industry development in Spain, because sometimes, but the argument, the problem is the lack of solvency, it's the lack of seriousness, lack of accuracy. It's a rather matter of threat rather than opportunity. The example I'm going to give you, to bound on something that Marcus said, is what has happened in some 4 research permits we have around the area of Maestrazgo, around Teruel, in the western part of Teruel. And the same company asked us to commission these surveys in the Basque Country and in Catalonia. And initially, not because of what was provided by the Convention, according to the media, they would be interested in this source rock, marine, Jurassic rock formations, as the ones you can see in the pictures in the Upper Jurassic. And sometimes some people have also said that they may be interested in the Triassic rock formations, but some of the ones providing some opportunities would be these Upper Jurassic rock beds. But in the Maestrazgo, Upper, Medium, and Lower Jurassic rock formations, we have the richest aquifers in the area, and simplifying in red, you can have the potential hydrocarbon rock beds, a potential water-resistant barrier, and then an important. There's a huge sponge encompassing all the Jurassic and the Cretacic. And the Lower Jurassic is the one having the strongest water sources and is the water used by many different municipalities and locations. And this model is very different from the US-based model. There's not even 500 meters of protection barrier. Sometimes there's a 0-meter barrier. Hydrocarbon formations are just side by side to water resources. So here you can see in red Upper Jurassic, which is source rock, and then Maestrazgo, the map of the different formations. The structure would be around the coastal areas, in tourist areas, in Peñíscola and Castellón, where you would have the pollution would go all the way down, and regardless of all the area where the pollution source would be produced. And this looks like a little bit lack of preventing measures in the area of Maestrazgo, especially in Castellón, not in the interior, is full of active faults that are well known, and they are the ones characterizing the profile, which is a recent tectonic profile, and some movement rates have already been assessed, and they are considered as active faults. Everybody would say we need not to touch them, and nobody has considered that. If fracking was done, was executed, maybe we should be learning from what happened in the gas stock platform, in the Castor platform. There has been a lot of earthquakes due to the injection of water to obtain the initial gas at a very lower pressure than the water is injected in fracking. So in the sea-based platforms, faults with the same behavior, the ones that have been mapped for some years now, that should indicate a possibility of induced seismicity that was not even taken into account in the surveys done by the company requiring the authorization. I think that we cannot accept such a degree of lack of seriousness and accuracy coming from companies that apparently just profit-looking companies and look for dividends and do not apply the principle of caution. The ambiguity in terms of objectives, at the beginning they said that they would be working on Jurassic, then Cretacic, and when environmental reasons are given against them, then they say that they want to exploit shale, Pleistonic shales, and they do not state anything about the real potential. There's very few opportunities that have been proven and very huge threats, at least on that particular region I'm fully familiar with. Other regions I'm not aware of, but to my knowledge, and it absolutely coincides with the conclusions of the expert survey, the expert report of the area. This indicates that it's absolutely not acceptable, this type of projects, to be carried forward. I think that I'm on time. So if I still have 15 seconds left, I would like just to read in this double language, which means to highlight the opportunity of shale gas in Spain and in Europe, not when it's a matter of calculating deposits of exploitable resources. Figures are exaggerated, but when the thing is to face environmental hazards and dangers, everybody just looks somewhere else. So, and everybody states that everything is under control and everything is going to be done properly. But when projects are so controversial and they lack such an important degree of accuracy, threats are not taken into account. So that would be everything. Thank you.